All right, young scholars. Hopefully you watched the video on Tuesday. Today we're going to go through inheritance and polymorphism examples. First, we're going to create an animal class to show inheritance through dog and cat classes. Then we're going to create an abstract class shape to show how polymorphism works for circle and rectangle classes. Then we're going to create an employee class to again show how inheritance would work through manager and engineer classes. We're going to create an instrument class to show polymorphism through guitar and piano classes. And lastly, we'll modify last week's circle inside a circle using inheritance. So I'm going to start by creating our first class called animal. So first, we create our class animal. And what do animals do?
Make noises.
Okay. So we'll call that speak. We're going to create a method void speak. It's simply just going to print out animals make noise. Make sure to always have your colon at the end, semicolon at the end, right? So after that, we now create our class dog. But if we're using inheritance, what does it need? Anytime you see extend, means you're inheriting. So in this instance, class dog extends animal. And we're going to do an override in order to tell us what kind of noise a dog makes. What noise does a dog make?
Because woof.
Okay. Dog woofs. And make sure you close that out with your semicolon. Then we're going to do a cat. Again, your subclass extends your superclass. Again, we need to override so that if it's a cat, it overrides animal. Again, our void speak. What noise does a cat make? Meow, right? So here the cat meows. But we need to call all of these methods. So we need public class animal demo. With our method, public static void, main, string args, so that we have a string argument. And we're going to do the same thing we did last week. Create an object of our dog, and then an object of our cat. Notice how we made them animal dog, animal cat. It allows us to inherit from the animal class. We then lastly have to call those speak methods from the dog class using dog.speak, from the cat class using cat.speak. And when you compile and run that, what happens? See our results? The dog woofs, the cat meows. Because our method is only in our class animal demo. So it ignores our animals make noise because of these overrides. Fairly simple, right? We're just extending or inheriting information provided from the initial class. So you tend to want to use inheritance whenever you have a situation where you don't want to write a lot of code. If we had to write this without inheritance, all within our class animal, it would be twice as much code. So we just create inheritance through cat and dog, and it's what? Let's see, 1, 2, 3, 4, 5, 6, 7, 24 lines of code, as opposed to, say, 50 if we had to do all this without inheritance. And as always, I'll post these example codes up onto Blackboard once we're finished with class. The next, I'm going to create, as I mentioned before, a shape class to show polymorphism. Polymorphism allows us to basically change how something is used. So we create an abstract class shape. And just abstract void draw. And we create class circle, which extends the shape. And again, we need to override. So what are we overriding here? Our abstract void draw. So we need void draw. And all we're going to do in that method is to tell that we're drawing a circle. Since we also want to do the same for a rectangle, we do the same. Class rectangle extend shape. Notice how on my screen an error is popping up? It's because we have not put in the override yet to do the same. Now, what are we going to put in within this class? Just as we did in the other one, but instead of drawing a circle, we're going to draw a rectangle. So in this instance, our shape is being used in multiple ways, as a circle and as a rectangle, hence polymorphism. But then we need to create a class with a method inside similar to what we did previously. We create an instance of our circle. And then we need to create a new instance or object of our rectangle. But in this instance, instead of dog and cat speak, we're calling the draw method for each. So what is the difference you notice?
That you have to add dot draw afterwards. The new.
Okay, we do dot draw instead of dot speak. Is that the only difference you notice? Usually within polymorphism, you're going to use either an abstract class or what's called an interface class. And we'll touch on that more in 2 weeks with abstract classes and interfaces, I believe. So when you compile and run this, now instead of dog woofs, cat meows, it should say drawing a circle and drawing a rectangle. Let's double check. Because I have both of them open in the same project, it displays all of them. But on your screen, when you compile and run, it'll probably just say drawing a circle and drawing a rectangle. That's exactly what our circle.draw and rectangle.draw are doing, because we created these methods that we're calling on. So void draw for both circle and rectangle are implemented below. Just as in the other example, we implemented our speak method we created. So fairly simple, right? Again, you tend to use these, whether it's inheritance or abstract, for polymorphism when you want to write less code. So next, I'm going to create an employee class to show inheritance from an employee class to a manager and engineer class. And these are obviously very basic examples. So every employee has a name, right? So we need to create a string called name. And create an instance of name. Within this employee, pass the string name, and then we create an instance of name using this.name. We're then going to create a method called void work, which is going to print out and tell us that name, our string that we created, is working. Well, what should I put before the is?
A space.
Yep. This way, when that outputs, it'll be name plus space is working. So we're creating an instance of basically a person within the employee class. So, it could be Calvin, Zaza, Brian, whatever. We then create a class manager, which extends employee. Well, we have to create an instance of a manager. So we again pass that string name. Initially, we created an employee. Now we're passing it into manager. And in this instance, we use super. Hopefully you saw that in the slides on Tuesday. We are taking from our superclass employee and dragging it into our subclass manager. Without that, we could not use the variable name. But if we want to override our system.out print line, what do we have to do?
You have to write override.
Yep. We have to override it. And we're going to create a new method called work. And what would I want to say if the person's a manager? What do we need first? Nobody? We need the variable name. We don't know who it is until we tell it who it is. And what would go in our quotes?
Is the manager on shift? Name
Okay.
is the manager on shift.
So remember to include that space after your first quote. So now it's name, whoever the person is the manager on shift. If we wanted to assign a role of engineer, we then do the same. Class engineer extends employee. But again, we need to take that string name from our superclass. So we create an instance or method of engineer, which passes that string name from the employee class, which is the superclass. Our engineer is one of the two subclasses we're creating. So now what do we have to do?
Overriding.
We got overriding it. And we create another work method which prints out our name and what should be the text for the engineer.
Is the engineer?
Okay. Do you want to say engineer on shift or just is
Sure.
the engineer?
Sure.
Okay. So I'll match it up with the other one. Is the manager on shift? Is the engineer on shift? Then lastly, we have to do the same as we did before. Create a class to display all that. So I called it public class employee demo. We create our method. And what do we have to do with our manager and engineer?
Give it a name.
We have to create an instance of them as objects. So employee manager equals new manager. Employee engineer equals new engineer. But do these look right? What's missing? Do they have a name?
No, they
No.
don't have a name.
Nope. We need that name variable. So who wants to be manager? Amelia, you want to be the manager?
Sure, I can be a manager.
So since we were passing the name variable, we have to include that or we create a new object of our manager and engineer. So for the manager, we assigned Amelia the role, and strings are always in quotes. Who wants to be the engineer? Franny, you want to be the engineer?
Sure.
Okay. So Franny is now the string name for engineer. And what do we need to do to display that? We did the speak method previously. We did the draw method. What's our new method we need to use?
We called it work, right?
Yep. So we would do manager.work. It calls the manager's work method. And then what we have to do for engineer.
Engineer.work.
Yep. Engineer.work, which calls the engineer's work method. So what's going to be displayed when we compile and run this?
It's gonna say Amelia is the manager on shift and Franny is the engineer on shift.
Exactly. So we compile, then run. Amelia is the manager on shift. Franny is the engineer on shift. Fairly simple, correct? Instead of writing 80 lines of code in this example, it's close to about 30. That's what inheritance and polymorphism help us with. We use this override to override the void work method in our first class, our superclass employee, but we need to use this super name in order to inherit the name from the superclass into the subclass. If we did not do that, we wouldn't be able to output name is manager on shift, name is engineer on shift, because we wouldn't know where this variable name came from. We'd have to create it again in our new class. So by inheriting, again, it saves us quite a bit of lines of code. So next, I'm going to create a class called instrument. Where in this example, I'm going to show you polymorphism with interfaces related to music instruments. So instead of abstract class, we do interface instruments. And again, like I said, we'll cover abstract classes and interfaces more in depth in 2 weeks. So what do instruments do?
Why did it end up changing into interface instead of class?
I'm just providing this as an example because when you're using an interface, sometimes you might want to display something. Like for an instrument, you might want to show an interactive interface. Like we did with the frame, drawing the circles, it's similar.
Oh, okay, thank you.
So what should we call this method? What do instruments do? Or what
They
do
make
you
music.
or what do you do to an instrument?
You play them.
Okay? So we'll call this method void play. So if we're going to use a guitar, instead of extends, because it's an interface, we use implement. Class guitar implements instrument. And you'll see here, this error method, guitar is not abstract and does not override abstract method play in instrument. So what do we need to put there?
Override.
Yep. You need to override the void play method from the interface instrument. And we create public void play in order for everybody else to be able to use that play method we've created within guitar. So what kind of message do you want to display for playing a guitar?
The guitar sounds good.
Okay. So anytime we run the play method within guitar, it will say the guitar sounds good. We do the same thing if we want to create a piano instrument. So class piano implements instrument. Again, we have that error pop up. We haven't overridden anything, so we need to produce an override. Now, what do we do for the piano? What do we do for the piano? Same thing we did for the guitar. You have to create a public method play that'll print out something. So somebody wrote in their intro post that they play piano, didn't they?
I might have.
Okay. So, Amelia, what do you want to display if you're playing a piano?
Mm, Piano Man.
Piano man. Okay. Now, what do we have to do last?
Oh, you have to demonstrate it.
Yep. So I create public class music demo where we create a method that is going to produce instances of these just as we previously did. So we create a new instrument guitar. And a new instrument piano. Do we need anything in between our parentheses?
No, it's provided already, right?
Yep. In the employee demo, we were using a variable name to show you how to inherit the name variable from the superclass employee into the subclasses. In this example, like the animal demo and the shape demo, we're creating the strings ourselves. So there's nothing we need to pass along. Now, how do we call these methods? How do we call them? We've done them all.
Piano dot play,
Okay.
guitar dot play.
First, we need to do guitar play. Calls the guitars play method. And then piano dot play. Which calls the piano's play method. So now when you compile and run this, it'll say the guitar sounds good and piano. So again, like I said, we'll cover abstract classes and interfaces let's double check here. I believe it's in 2 weeks. Or we'll go more advanced into that. Yep. The week of 10/10. We'll go more advanced into abstract classes and interfaces. So last but not least, you're going to have a homework assignment,
Oh, yes.
number 5, where you're going to be asked to write a Java program using inheritance that will draw a circle inside another circle.
You're gonna be there.
Basically, you're modifying your work from last week to now use inheritance. I'm going to call this circle as my class. Who remembers the imports we need from last week? We need to use 2 imports. Java.awt.asterisk, which allows us to import everything from that package or class. And then import javax.swing.asterisk, which allows us to import everything from the package javax.swing. So we're going to extend JPanel, just like we did last week with our circle. But what do circles have?
A radius?
Yep. So what kind of type would a radius be? It's usually a number, right? So you want to make it an integer here. And then we need to pass that radius and create an instance of it. Just like we did with our employee name. We passed that string name, created an instance of it using this. We're doing the same with our circle. Passing the int radius and creating an instance of it. But then we need to override. Utilize our paint component method. Who remembers what we passed in that from last week? Anybody? We have to create a graphics variable G that we can pass. So within that, instead of what we did last week, we now have to have super dot paint component with the graphics element G. Super allows us to inherit from our initial super class circle. Then we have to get our height and width. First, we're going to draw our outer circle. I'm partial blue, so I'm going to set the color as blue. Then in order to draw that, we take our center X variable minus the radius and our center Y variable minus the radius and then radius squared twice. Then we calculate the smaller circle's radius. So it's going to be an integer. It's just going to be the radius divided by 2. Then we're going to draw the inner circle. The inner circle, I'm going to make it red. Then we do the same thing to draw it. But instead of minus radius, we subtract the smaller radius we've just created. Instead of radius squared, it's smaller radius squared.
That's not squared.
True.
Squared is times itself.
2 times radius, I'm sorry. Got my formulas mixed up. So what are we missing here?
Implementation. I mean, you know what I mean? Like when you use it in an actual formula.
We're missing the fact that this all goes within that class. So I had all of this below our closing bracket for our class. It should all go inside of it.
Okay, yeah, I was wondering why it was yelling at me.
Once we fix that little misstep, what's the last thing we have to do? We have to display the circles, right? So we create a new class that's going to display those circles. I called it public class circle drawing. where we create our more common method. But what do we have to do first? Where do they show up on? A frame, right? We have to create an instance of JFrame. The JFrame frame equals new JFrame. And then inside the JFrame, we have to give it a display name. What do we want to call the frame? Nobody? Let's just call it drawing circles with inheritance. Then we have to set it so that when the X is clicked, it's going to close our JFrame window. The frame dot set default close operation, JFrame dot exit underscore on underscore close. That makes it to where you hit the X, it closes the frame by default. So we've set a radius and a smaller radius. What are we missing? What did we not set?
We didn't set the X value or the Y value.
Okay. The X is dependent on the radius.
Oh, okay, I thought it had to be a different one for the other circle.
Yep, it is. We set it here, center X minus smaller radius, center Y minus smaller radius. We didn't create an outer radius.
Taking that from the int, center X above it. Yeah,
This,
yes.
we're getting the width, dividing it by 2.
No, what I was trying to understand is that you don't have to do that for the other circle. It's still the same.
Right.
Yeah,
Because in the first instance, we're just using the variable radius from our circle superclass. And in the second instance, we're subtracting smaller radius, which we created int smaller radius is radius divided by 2.
Okay, I see that now.
So notice how for the smaller one, we're using that variable here, smaller radius. We're at center X minus smaller radius, center Y minus smaller radius, 2 times smaller radius twice. But because we have an inner radius, we now need to establish an outer radius, which will be our radius of the outer circle. Now we create an instance of our circle panel from above. Well, why would I create outer radius? Well, we're now going to pass it to that new circle panel we've created. because we're going to set the size of our frame to make sure that it includes the outer circle. Who was it? Somebody for last week's assignment did a for loop, and it showed a bunch of circles and a couple of them were cut off.
Yeah, that was me. I figured out how to make a bunch of for loops, a for loop to make a bunch of circles.
So that's basically what we're doing to prevent here, so that the outer circle is entirely in the screen and visible, which is why we're creating the outer radius. So next, we have to add that circle panel to our frame. Otherwise, nothing's going to show up. So again, we're passing this outer radius variable to make sure that the larger circle fits within our frame. So then we do frame set size, 2 times outer radius, plus 50, 2 times outer radius plus 50. That gives us a little leeway. This way we can make sure that everything is inside our frame. And last, we need to set the visibility to true. So frame.add adds the object onto our frame, our view. But without this frame.setVisible, it's not going to show up. So those 2 lines of code are very important. And then we compile and run. And our JFrame pumps out a blue circle and a red circle. Notice how when it pops up initially, it's in the smaller size window. Our frame is set up to make sure that the outer circle shows up. So those that are in the mobile apps class, this line of code here, frame.setSize 2 times outer radius plus 50. Basically the same thing we talked about yesterday with padding. It makes it so there's a little space in between the top and bottom, left and right. And basically you're going to do the same thing that I just covered there for your homework this weekend. Homework number 5. You're being asked to write a Java program using inheritance that will draw a circle inside of another circle. Literally just showed you how to do that. It's inheritance because we're using the override. We're using our super class to import into our subclass. You're more than welcome to also fill the oval, like I did with the triangle example, but that's entirely up to you. It's perfectly fine to just have the simple line, blue and red. You know, you could have both set up as black. That's entirely up to you. I'm not picky. Okay, so are there any questions related to that?
So basically what we just did now is basically like what we're supposed to do for homework.
Yep. Like I said, you may want to change the colors. I used blue and red. You might want to change it to your favorite colors.
Okay.
You might want to change the, see how here it says drawing circles with
Yeah.
inheritance? You might want to change what your J-frame display is. That's perfectly fine.
Could we keep it the same, or do we have to change that?
You can keep it entirely the same.
Okay.
Like I said, you could add a fill color to fill in the entire circle to be red and blue. That's entirely up to you. Okay, so that's much easier this week than last week. Our 5
Thank you.
examples last week took us quite a bit of time. Okay, one last thing. Some of you did not submit homework assignment 4 last week. I got a couple emails. Last week's assignment, write a Java program using objects in classes that will draw one circle inside of another. I showed you an example of that last week. Excuse me. For those of you that did not submit it, make sure you submit it to me by later this evening, 11 p.m. I have to submit the progress reports for both of my classes. So make sure you email me your code for that homework assignment number 4 by 11 o'clock tonight, and you'll get credit for it. Because a lot of people in both classes were emailing me indicating that they thought the project was due this weekend instead of the general homework. Okay, so last but not least, as I mentioned, next Tuesday I have a doctor's appointment. So I will again record the lecture ahead of time and plop it in next week's folder for you. And I'll have a similar post on Blackboard about my availability Monday, Tuesday, Wednesday, if you have any questions. Very simple next week, though, since we're just talking about exception handling with text input and output. So next Thursday, we'll go over 4 or 5 examples. And the homework for next week is fairly simple, where you're just going to create an exception and write a comment showing that you know what the exception is and how to handle it. And as always, I have extra videos here if you want to look through them and learn more, or perhaps my information provided wasn't as clear as it could have been, or you weren't sure. They're always there for you to look through. So are there any questions?
So every assignment that we're missing, we have to submit it today, right?
So if you did not do homework assignment number 4 that was due last Monday, you have to submit it, email it to me by 11 p.m. tonight, because they have the progress reports are due tomorrow morning. But because I think it's already closed on Blackboard, like I said, you'll have to email it to me. And like I said, I'll give you guys that freebie because I had at least 6 students between both classes emailing me saying that they thought that the project was due this weekend instead of the homework. So if you did homework 4 already, don't have to worry about it. Just focus on submitting homework 5 by next Monday night.
Okay, thank you, Professor. Goodbye.
If there are no
Thank you.
questions, go ahead. Have a good night. Enjoy.
Thanks, Professor. See you.
You too, Professor. Thank you.